Hello and welcome to another flipped lesson. I am Mr. Bridges and we're going to talk about factoring today. And it should be a review for you guys. So as we go through here, we have the target 2D solve polynomial function using various techniques, and the one we're going to discuss today is factoring. So the first example, we have a trinomial, x squared minus 6x minus 16. So hopefully you guys have somewhat familiarity with factoring, but if not, I mean, that's what kind of this video is about, is reviewing some of these concepts. So we're going to look at negative 16, and we want to think of two numbers that multiply to that, and then we want to be able to add to negative 6. So that gives us x minus 8 multiplied by x plus 2. And there's our nice reminder. If the leading coefficient is 1, we're going to add or subtract to the middle term, the b value, and multiply to give us the last term, which is our constant. All right, so number 2, we're going to try to factor that. Two numbers that multiply to get 6 and add to get 5. So our factors of 6 are 1 and 6, or 2 and 3. And then the plus 3 plus 2 will give us the plus 5 that we need. If you distribute that, you can always check to see if it works back to the original. Why don't you guys now pause the video and factor number 3. Okay, and welcome back. Let's check your work. You get x minus 8 times x minus 3. Negative 8 times negative 3 will give us positive 24, and minus 8 minus 3 give us negative 11. The next type of factoring that we're going to talk about is what if we have a GCF, or if a is not equal to 1, we have greatest common factor in there. The first step is to factor out the greatest common factor, and then we're going to do everything that we just did before. So 2 is in every single one of these terms that we can factor out, and so is x. So once we do that, we're left with x squared plus 8x plus 15. So after that, we will factor it again to 2x times x plus 5 times x plus 3, thinking about what factors of 15 will add up to give me 8. Go ahead and try this example on your own. Pause the video. Right, and welcome back. Hopefully you guys figured out that 3x was the greatest common factor, and then we are left with the trinomial x squared minus 3x minus 18, and go ahead and factor that one more time to give us x minus 6, x plus 3. If at any time there are questions, pause the video, write them down, and we can discuss them tomorrow in class. 2 by 2 grouping. If we're given 4 terms, we can then use 2 by 2 grouping. The first step is to split them into 2 groups of 2 terms each, factor out the greatest common factor, which we just talked about, into each one of them. So as you can see, x squared is in the first 2 terms. What is left over is x minus 2. We can factor out a 3 in the second bunch. The purple is what we're talking about here. And then what is left over is x minus 2. If you do it correctly, and this is really important, the resulting binomial in each group should be the same. Not saying if you do it correctly, they're always going to be the same. Sometimes they're not, and what that means is it's just not factorable by grouping or at all. So they're both going to be x minus 2 in this example. So we have now a binomial that we put together. What we factored out, the greatest common factor, will be put together. So in this case, it's x squared plus 3. And then what is repeated in common is going to be x minus 2. So here's an example that we're going to go through, split it in half, take out the greatest common factor in each one of those. So in our first set, we can factor out an x squared. What is left over is x plus 3. Factor out a negative 4 from the second ones, and then what is left over is x plus 3. Now, if you did forget to factor out the negative, you're going to have x minus 3 left over, and then they don't match up. So at that point, you should, hey, what is going on? Am I doing something wrong? And then notice if you factor out a negative, factoring out a negative from a negative will make it a positive. So x plus 3 is repeated. That will be one of our factors, and x squared minus 4 is another factor that we have. And those are our 2 binomial factors. Now, hopefully you see something that's going on with x squared minus 4 as a little difference of squares here. And then we would actually factor it again, x plus 2, x minus 2. And then we have the x plus 3 left over. Other types of factoring, and we just talked about one of these, the difference of squares here. We're able to do x plus 7, x minus 7. What this tells us is if there is no b value, then we're going to be left in a situation or it needs to cancel out. How do we get to 0? We have to add and subtract the exact same number. In this case, how do we get 49 at 7 and 7? So we're going to look at taking the square roots of those numbers and solve it. So go ahead and pause, see if you can come up with x squared minus 16 and factor that one. All right, welcome back. Hopefully you got x plus 4, x minus 4. Okay, example 10 is a little bit different. We have x to the 4th. And we go back to monomial properties and properties of exponents, and we realize if we're really multiplying two terms, we add exponents. So in this case, excuse me here, sorry about that, we have x to the 4th. We want to be able to do that by adding 2 and 2. So we have x squared and x squared, and then x squared and x squared, when you add them together, stays x squared. So if you were able to go back, we're just going to cut this number in half, and that should be the same number here. And the same rules apply. What two numbers multiply to get us 16, and what two numbers add up together to get 10. So our next one we're going to look at is x to the 10th minus 5x to the 5th minus 6. So how do I multiply two terms to when we add the exponents, we get 10? But also they have to have the same number as the middle term. All the good news is 5 and 5 actually do make 10. In case you didn't know that, look it up. So x to the 5th times x to the 5th does give us x to the 10th. It is not x to the 25th. We add exponents. X to the 5th is x, 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 and then x to the 5th again is 5 of them, so 5 and 5 make 10. We got to get to negative 6, so negative 6 times 1 gets us negative 6, and negative 6 plus 1 will give us that negative 5. Okay, so the last part is actually going to take this a step further and find x-intercepts. So we're going to be able to factor this same way as we've been doing. X minus 5 times x minus 1 equals 0. Now we get into the zero product property, which states if either one of these binomial factors is equal to 0, 0 times anything is 0. So we're going to come up with two solutions here. X minus 5 equals 0 and x minus 1 equals 0. These are just simply one-step equations where we do the opposite. And again, this is the same reason why when we are looking at vertex form and all these other things, it's set it equal to 0, because we want to know when y is 0. Okay, so if we can find something 0 times anything gives us 0, which is why we set it equal to 0. Another one, this time we're going to have grouping, so we can factor out our x squared and get through the entire process. We're going to get x squared minus 4 plus 1, which again we did an x squared minus 4. That's a difference of two squares. So we get x plus 2 times x minus 2, x plus 1. So we should have three answers here. Set them all equal to 0. We get a plus or minus 2 and also the negative 1. Alright, so our last part is going to be fill in the blank, talking about factors and x-intercepts and everything else. X minus 4 is a factor of f of x, then x equals 4 is going to be a 0. If negative 2, 0 is an x-intercept, then the factor is going to be x plus 2. Again, we're looking at opposites here. If we have a solution x equals 0, in this case x equals 5, is a solution of f of x equals 0, okay, then we know that plus or minus 5, sorry about that, it's x equals 5, so we want to do the opposite of a positive 5, which would make it minus 5. If x minus a is a factor, then x equals a is going to be that 0. And a comma 0 is an x-intercept, and the factor will be x minus a. Notice that in this example, a is positive, so we're always going to be doing the opposite there, because we want to set it equal to 0 and solve. So if x equals a is the solution, then x minus a is going to be the factor. So that is a review on factoring. We were able to do trinomials and binomials and grouping, and then eventually worked on solving them to find the x-intercepts and our zeros. So I believe that is all. If there are any questions, write them down and we will discuss for tomorrow. Have a good night.